Hello students, in this video I will be taking new chapter, that is circle. I have already discussed about triangles in my previous videos, and so now let's continue with circles. So first thing first, what is circle? मान लीजिए आपका कोई फ्रेंड है, आपने उसे कॉल लगाया और पूछा कहाँ हो तुम, वेयर आर यू, एंड ही सेड कि आई एम 5 मीटर अवे from SBI Bank. Suppose this is SBI Bank and your friend said that he is 5 meter away from the SBI Bank. 5 meter away. So how will you find your friend? He could be here, or your friend could be here also. He could be somewhere here also. Could be somewhere here also. Could be somewhere here and here and here. There are like many possibilities where he could be, and if we collect all those points where your friend can be, then we will form a circle. So in mathematical language we can say that the circle is collection of all the points which are at a constant distance, which are at the constant distance. This is the constant distance from a fixed point. This is the fixed point. Okay, from a fixed point. This is the fixed point and this is the constant distance. So circle is the collection of all the points in a plane which are at a constant distance from a fixed point, and this constant distance, this constant distance is called radius. This is called radius, and this fixed point is called the center of the circle. Is called the center of the circle. So now moving further, there is another term called secant. Okay, so let us suppose this is a circle with some center O, and this is a line which is passing through the circle, and this line intersects the circle at 2 points. So this line is called secant. Okay, this line is called secant, and many times in our questions we are concerned with this length, the length which falls inside the circle. This length, like let us suppose it intersects the circle at 2 points. This is A and this is B, and in our numericals we are most of the time we are concerned with this length. So इस लेंथ का भी हम नोमेनक्लेचर करेंगे, तो इस लेंथ को हमने नाम दे दिया chord. This is the chord of the circle, and this whole line is secant for the circle. And now there is a special case of secant, like let us again take a circle with some center O, and I'll draw a secant. Secant can be anywhere. We can draw secant anywhere. It can be here, it can be like this. The only thing is it should intersect the circle at 2 points. It should always intersect the circle at 2 points. So now let's take one secant and which intersects the circles at 2 points. Then it lies inside the circle. Let's move it a little upwards. Still it lies inside the circle. Then let us move it little more upward. Still it lies inside the circle. Then there will come a point when this secant will exactly touch the circle. This will exactly touch the circle, and then it will intersect the circle at only 1 point. here it was intersecting at 2 points, 2 points, here also 2 points, and there will come a point where it will touch the circle at only 1 point. So this line we will call it tangent. This is the tangent of the circle, and if we move this line further upwards, then it will lie outside the circle. This is the defining case, means it's just touching, it's neither inside the circle nor outside the circle. So this line is tangent. What is the property of tangent? That it intersects the circle at only 1 point, and this point is called point of contact. The line, the tangent where it touches the circle is called the point of contact. This is the point of contact. Okay, so we are done with the basic definitions in the circle. So now moving forward to another theorem. Here we have seen a tangent at a point on a circle. Now we will look for a theorem of tangent from a point lying outside the circle. So this is a point lying outside the circle, and from the point lying outside we can draw two tangents, as I have already explained that from outside, point lying outside, we can draw exactly two tangents. Okay, so let's draw two tangents from this point. Tangent this, and then the tangent is this. This is the point of contact. Let this point be A, and this be P, and this be Q. And this is the center of the circle. Then the second theorem says that the length of tangent. What is length of the tangent? This length, AP and AQ, is the length of tangent. So theorem says that the length of tangent drawn from an external point to a circle are equal, which means that this and this are equal. So let's write the theorem. The length of tangent drawn from an external point to a circle are equal. Again, the proof has been asked in CBSE board exam many times, and its proof is very important. So what we have to prove? We have to prove that AP is equal to AQ. Okay, so we'll make some construction here. We'll join this and this. Okay, this is the radius. OP is radius, and also OQ is also radius. Okay, so from theorem 1, what we can say, that this is perpendicular. Okay, at the point of contact it's perpendicular. Theorem 1, which I have already explained here, that this angle is 90 degree. So again this will be 90. This both angles, angle P and angle Q, will be 90 degree. And another construction which we will be doing is joining AO. So if we can somehow prove that the triangle A, this triangle APO, and triangle AQO are congruent, then it's implied that AP will be equal to AQ. So let's try to prove these triangles to be congruent. So first thing which we are given is angle P is equal to angle Q is equal to 90 degree from theorem 1. Okay, and then what we have OP is equal to OQ, yeah, because both are radius, so they will be equal. And the side OA is equal to OA, as this is common. Okay, so by RHS criteria, similarity, RHS congruency, these two triangles will be congruent. Okay, so if they are congruent, then we have what? We have triangle APO is congruent to triangle AQO. Hence, we will have AP is equal to AQ by CPCT, congruent parts of congruent triangles. Okay, so from here, as the triangles are congruent, we can also conclude two more things. The first is that the tangent subtend equal angles at the center. That means this angle will also be equal, okay, because the two triangles are congruent. So it means that the tangent subtends equal angles at the center. This is the first deduction from the above theorem, that they subtend equal angles at the center. Second is this angle will also be equal. This angle will also be equal. So what we can say, that second thing, that they are equally inclined. This is called inclination. This angle is called inclination. So we can say that they are equally inclined to the line segment. This is the line segment joining the point to the center of the circle. This is the point and line joining to the center of the circle. So these two tangents are equally inclined. This angle is called inclination. Okay, so these two deductions we can make from the above theorem.